you have entered the room early, as in all the previous ones, it'd be good to know where you're joining from, what time of day it is, what the weather's like. It's sunny and -2 in Yorkshire. And if you've been to, this is the fourth of the series, if you've been to any of the others. Hi, Amin. Hi, Shalima. Were you in on Tuesday, Shalima? There were a few people from Trinidad in on Tuesday. Thought you were. Thought I recognised the name. Hi, Sheldon. Trinidad and Tobago in the room first. Good. I'm glad you did, Shalina. And I think Sumi and Oman, I think you were here, weren't you, on Tuesday? Have you been to all of them? You've been to all four. We should give them a special badge if they went to all four, Catherine.
Well, they get a special certificate.
Do they get a special certificate for being at all four?
Yeah.
Oh, right, fantastic. Hi, Fahana. Hi, Stephanie in Jamaica. Hi, Kamoy in Jamaica. Bagashri, I probably said your name wrong again, but I recognise Bagyashri, should be, shouldn't it? Yeah, you were here on Tuesday, weren't you? I remember it being awful with your name again then. Sorry about that. So sorry twice. Hi, Avion and Carlessa on the same machine, presumably. Hi, Charmaine and Barbados. Lots of people in the Caribbean. That's great. Hi, Gaurav Kumar. I don't know where Dombivli is in India. Whereabouts is it? You're very kind, Bagyashri. I'm sure it wasn't correctly pronounced at all. Hi, Mark. Remember you from Maidstone, if I remember, or somewhere down south. Hi, Temi Tope. Whereabouts are you? It's great seeing people's names that I recognise. It's like going back in the room after a break and your class still being there. Do you recognise the names for the last 2 days as well with Andrew?
Yeah, Mark, yeah. I think has been to all four.
Okay.
Good time to come to England on holiday, actually, because the weather's actually okay this week. It's cold, but sunny.
Hi, Marissa and Sean. Lots of people in Trinidad.
Okay.
Hi, Monique.
Thanks, Mark.
That's the teacher in me, Mark. Hi, Nickel. Or Nickel. Hi, Jenny. I think Trinidad's winning. So quite a number of people. We get a little map at the end of each webinar. So on Tuesday, I think the most people in the room at one time was 255. And you get a little map which kind of maps out where people are, which is always lovely to look at.
Right, it's on the hour, 2 o'clock in the UK. So I think we'll kick off. Hello, everybody. Thank you so much for joining us today and giving up your time to attend this session. The last session of 4 of our Maximising Maths Part 2 webinars. Thank you if this is the first time you've joined us, or if you've been with us all week. Thank you so much for joining us with these webinars. Today we'll be joined by Tony Cotton, who will be talking you through geometry and measurement. Thank you very much, Tony, for hosting the session today. Everyone's using the chat box already, which is fantastic, so carry on doing so. The session today will run for an hour, and afterwards you'll receive the recording, slides, and your certificate. And if you've attended any of the sessions this week, you will be sent all of the recordings, all of the slides from the whole week. So if you've missed any, just keep an eye on your inbox and you will receive everything on there. And it will also be on our social media channel, so keep an eye out. Please do carry on using the chat box and enjoy the session. I'll hand over to Tony now. Thank you.
Thanks, Catherine. And Yeah, it feels like saying lovely to lovely to literally lovely to see you all again. The only problem with this platform is that I can't literally see you. I have to imagine you. Um, Hi Suha, hi Jordan. Nice to know that there's somebody in from Jordan. And hi Adira. Whereabouts are you joining from, Adira? I was talking to my wife after the session on Monday, and I think with these two sessions, I've probably run at least 6 sessions around Max Maths for Macmillan, and for colleagues in Belize. I've not noticed anybody from Belize, but I'm sure there will be some people joining from Belize. There's been probably about 10 sessions specifically for Belize around another program I've written for Belize, and all of those sessions pulled together are a substantial amount of CPD. Um, and I'd be interested in any feedback from any of you. I'll type my email, my personal email in the chat box so that you've all got that. And if I remember, I'll put it on again at the end. And if I don't remember, perhaps Catherine can remind me. So that's my personal email. I'm really interested in how effective you find these sorts of sessions in terms of your CPD. So when I work in universities in the UK on teacher education, it might be that those beginning teachers would only get 10 or 12 taught sessions around mathematics, which is similar to the sorts of number of sessions that you might have had. And similarly, I teach on an international PGCE for the University of Nottingham in the UK. I'm very lucky. That means I get to go out to Bangkok once a year. There were some people in from Thailand on Tuesday, and I recognised some of the names from Thailand on previous sessions. And again, the face-to-face sessions there are over 4 days, which might be the equivalent of the sorts of time that you spent listening to me or engaging with my ideas on these webinars. So I would be fascinated for any feedback, and if any of you would be interested in having a little bit of a longer conversation about kind of the impact of these sorts of sessions, maybe we could have uh, a chat over Zoom or something, because just to give me some more feedback and Macmillan some more feedback, because I do think it's incredibly important, these sorts of sessions that we have, which are around 200, and my guess is we might get up to about the 200 mark again for this session, up to 133 at the moment. 200 committed teachers from around the world listening to and commenting on and engaging with CPD. I think it's quite a powerful model. Um, so we've talked about place value and counting. That was Tuesday. You talked about calculating on Wednesday with Andrew, and you talked about algebra. Yes, yesterday with Andrew. It was Monday, wasn't it? I was on first. Monday, Tuesday, Wednesday, Thursday. Today's Thursday. Um, Hi Casion from Jamaica, and hi Carlin in Jamaica as well. Um, and we're moving to look at geometry and measurement. I suppose trying to cram two things. Now, in a way, it's interesting the kind of slant that we, and in fact probably I, have put on the mathematics curriculum, isn't it? So I originally suggested to Macmillan that we run 7 subject knowledge sessions. I said on Monday that I do think subject knowledge and our own confidence in being mathematical and doing mathematics is the most important thing in terms of developing our teaching practice in the classroom. Quite sensibly, Macmillan said seven would be far too many. Um, And those 7 would probably have been split about half between things that we might see as number and algebra, and geometry would have been a separate one, and measurement would have been a separate one, and there would have been one on data handling. Um, Now, interestingly, the decision I've made, and it was me, is to have 75%, so 3 of the sessions around number and algebra, and then just one looking at geometry and measurement, and we've kind of moved data handling out of these 4 sessions. Part of that decision was to do with the curriculum internationally. Not all schools all around the world look at data handling and statistics, particularly in primary school. So that was one part of the decision. Um, but what I don't want to give the impression of is that this is somehow a lesser part of mathematics. One of the one of the other jobs that I do is I edit mathematics teaching. I think I told you that on Monday, which is the journal for the Association of Teachers of Maths in the UK. Um, Another thing I would be interested in is if any of you are interested in developing writing about your classroom practice for that journal, email me on that same email. One of the articles that goes into every journal is one called My Maths. And that's an interview that I do with people who aren't mathematicians about the maths that they do as a part of their everyday life. And the first person I interviewed was my cousin Shane. And Shane's an artist, he's a sculptor. And I interviewed him because, like many of my family, they sort of see me as a bit of an outlier because they see me doing maths and they think they can't do maths or they don't do maths. What they mean by that is that they weren't successful in mathematics at school. Catherine said to me just before we opened the session up that throughout the algebra session yesterday, she was thinking, if I'd have been taught like this, I would have understood algebra. Now, I was interested in that because on Monday she said to me about she said when she opened the session that she wouldn't be able to do the mathematics. And it was a good job I was doing it and not Catherine. And even over those 3 sessions, it feels to me like Catherine has realised that it wasn't her flaws in being mathematical at school. It was her teachers not being able to explain it to her so that she could understand it. Now, of course, to be a sculptor, you have to have a very deep and a very intuitive understanding of lots of mathematical ideas. When I interviewed Shane, he was talking about projects he was doing in school as a sculptor, but one of those projects was maze making mazes, and another of those projects was based around road signs. In England, they're very old. They're called mileposts, and they used to mark the distances between towns. So these are mileposts from the 19th and 18th century. And they are artistic artifacts as well. And he was redesigning those with children. So clearly, mathematics involved in that. The last person I interviewed was a musician called Tony Wright. Um, and he is a builder, he's a printmaker, and he runs a coffee shop. But he still talked about mathematics as something that he couldn't do, again, remembering his failings at school. But to be a musician, you have to understand and follow patterns and know what happens if you slightly change the pattern of your fingers in terms of sound. And we were talking about that, and he said, "Oh, maybe I hear mathematics rather than see mathematics." And then we talked about building, and he said, maybe I see mathematics in the finished building rather than can do it on paper. So he began to see mathematics as something that he could do, but he'd never really made the connection between his day-to-day practice, which I think is mathematical, and the mathematics that he was fed at school. He described his education in terms of maths as a kind of here we go again education, meaning that it felt like the teachers were coming into the classroom with the same old maths textbook, looking at maybe new faces and sort of feeling, here we go again with the same area of mathematics. So no kind of passion and no kind of excitement and no real attempt to link it to Tony's passions and interests. So in a similar way that we started on Monday, can I ask you to feed into the chat the last time that you noticed shape and pattern in terms of appreciating the world around you, the geometry of the world around you, but noticing the geometry of the world around you, and the last time that you found it necessary to measure in order to either carry out some task or solve a particular problem that you needed. Morning, Valerie. Whereabouts are you, Valerie? And hi, Gagandeep in India. Great to have so many people from India as well. It's a great day in England too. I'm glad it's a great day in Barbados, Emma. I bet it's warmer. It's -2 here, I was saying, but it's warmer than that in Barbados. I remember on Monday somebody talking about tailoring. Yes, and so isn't it interesting, Mark, that so the geese, maybe it was geese flying, and I'm not sure whether they're arriving or going. I saw some geese flying over the roof of the coffee shop just in front of me this morning. Um, they're using mathematics so that they fly in the V shape, and that's to do with cutting down, being more aerodynamic, isn't it, as a single unit? And there's suggestions that they kind of map read as well, that they have a sense of the geometry of the terrain that they're flying over. And were you making a table covering just out of one piece of material, Emma, or putting pieces of material together? And did you think about where to cut the material, the impact that would have on the pattern? Um, Thanks, Lauren. I think in terms of you say, okay, Mark, thanks. Swallows, right? Interesting. No measurement, but estimation. Estimation is a really important part of measurement, isn't it? And we'll talk about that and what that estimation is based on and what effective estimation is based on is your experience, is noticing particular measures. And what we'll talk about a bit later on is measurements that we know or we have a sense of, and measurements that we don't have a sense of. So we might have to go and get a ruler or some sort of measure. Hi, Alessia. Yeah, no, patterns on surfaces, which could be dirt. Yeah, we'll have a look. Think about buildings in a minute for Hana. Um, Amazing symmetry and the sorts of calculations that have to go on there. Was it you that talked about tailoring on Monday, Emma? Um, and being a seamstress. Great that you were working with. How old's your daughter, Amin? Because that's a really important thing to do, isn't it? Oh, fantastic, Sheldon. I run a record club in the coffee shop just in front of where I live, and this evening is a record club, and we occasionally have to mend the speakers, and it's where people bring their vinyl records, so it's a vinyl record club. Um, maybe I ought to tour it around all these wonderful places. So lots of measuring, lots of geometry. And sometimes I think people see that as a lesser branch of mathematics. I'm going to claim it isn't. And that what we can do through geometry and measurement is sometimes that's where confidence in being good at mathematics can start. So my argument with both Tony and Shane that I interviewed were if you can do that mathematics, if you can be skilled in geometry, then you can be skilled in the other areas of mathematics because you are good at mathematics. You can't measure without being good at number. even if it's estimating, whoever it was that was talking about estimating, because that's to do with comparing and thinking about more or less than, which is all to do with number. So you can move across those ways. And for Hannah, you you may estimate, or you may have been weighing, and if you were weighing, then you were certainly using numbers, and numbers will make sense to your daughter in terms of when she's cooking. Now, I'm not going to go through all of the introductions again, but what I find interesting, when I'm putting these presentations together, is the slides that I might choose to introduce myself, because I think that tells the people who are listening something about my values and my priorities. So the photograph there on the left is a workshop in Belize in November. Um, and that's in the north of Belize, right in the north of Belize, just on the Mexican border. I think it was about 20 miles from the Mexican border. And the instruction to those teachers, and it's an activity that I quite often use with school students, was to make a square so that all of the teachers were equally placed. You can see that they're holding their elbows akimbo, as we say in the UK, pointing their elbows. So we actually did have a square. Now, in order to do that, obviously they had to do some counting and some dividing and some thinking about dividing by 4. Squares are interesting because you can play about with the people in the corners if it won't divide exactly by 4. And you may just pick me out in the middle. And I quite like the idea of me just being in the middle of an activity that's going on, that there's mathematical activity going on that's been maybe inspired by something that I've suggested, inspired by something that you've seen in Max Maths, but the activity is what's important, what everybody's engaged with, but the teacher's somewhere in the middle kind of directing that's going on. And then on the outside, the right hand side, that's me in my tatty old scarf and hat, and two of my grandsons, 2 of the 4 of my grandsons, and my middle son Adam. You'll notice they've got Lego bags. Felix will spend all his time making Lego, and that is an incredibly mathematical activity. And we engage in lots of mathematical conversation, particularly geometrical conversation, but also in terms of measurement. How long does it need to be? How long is that piece? How big is the gap? As well as describing the shapes. Tate, the one doing the pose, is really into board games. He's only 5, but he's really into board games. And we were playing a new board game with Adam at the weekend. They've kind of got that from Adam, and it's about designing a zoo. But the pieces are all they're like Tetris pieces. Do you remember the electronic game, the video game Tetris, where you have things dropping down, and you have to rotate them around to fit them in gaps? And he's fascinated about how those things fit together. So he's doing geometry at that stage. And I think they've been inspired to do that by watching Adam, who they worship because he's their uncle, playing the games and making the Lego, making difficult Lego. So there's something there about us as teachers engaging in the type of activities that we want our learners to engage in and engaging with them. So if we're doing some geometrical work, if we're noticing pattern, if we're thinking about pattern, if we're doing measurement, and if by doing measurement we might well be making something, we need to be joining in so that we're modeling being mathematical to them. Again, I use this slide on Monday, and I just put it here as a reminder that subject knowledge isn't just about you knowing the maths. Subject knowledge is partly about you knowing the maths, And that knowing, I think, is to do with being confident. So I think Felix and Tate developed their confidence in school mathematics by being successful both in school and out of school, and by being able to make connections between their out of school maths and their in school maths. I'm I'm running a maths club at Felix's school, and in that maths club we do a lot of the activities that I might do with Felix and Tate at home, which immediately turns that into school maths. So there's not a difference between school maths and home maths. Pedagogical knowledge is how you teach the mathematics. So whenever you're planning a lesson, you've got a range of things you can draw on. Contextual knowledge is having a really good understanding of the place in which you work, the constraints and the opportunities that offers you, um, and the sorts of learners that you're working with. I often think there's a similarity between teaching and, say, coaching a football team or coaching an athlete. My daughter Holly was a very good hurdler, a sprint hurdler when she was a teenager and young woman. Um, and had ranges of coaches. The coaches she was most successful with knew her the best. So they knew the technique, they knew all the exercises that she needed to do to develop the appropriate muscles. They knew the routines that she should follow. When you're a hurdler, you do a lot of stepping over hurdles and bringing your trailing leg down really quickly just to get that sense of feeling how your trailing leg has to follow through, and you do that again and again and again. You practice that, and then you obviously you run the races where you put all of your learning all together. And there's echoes of the sorts of things we do as teachers in that little description. But her best coaches knew when she needed pushing because she was being a bit lazy, knew when they needed to back off because she was finding something difficult, knew when she needed extra support, maybe knew when they should say, "Tell you what, we'll not do that exercise now. We'll do that next time. Let's go and do something different." Um, it is, Lauren. It's exactly the same thing, and I think sometimes we forget about that when we're teaching maths. And maybe we forget about that when we're teaching maths because there's something in our heads that's a little bit more worried about the maths, and we forget how important that contextual knowledge is. And then the last bit is we need to know the curriculum that we're teaching. Hi Geraldine, whereabouts in Thailand are you? So, two images. And that actually did take that. I was lucky enough, it was my last pre-lockdown trip. I went to a wedding in Jaipur, actually of an ex-student. One of the great things about teaching is that sometimes you maintain relationships over many years with students, and we could spend the whole session thinking about the mathematics in the Taj Mahal, which is seen as one of the most beautiful pieces of architecture in the world, and is seen as that because of the symmetry. But it's not just symmetry. It's to do with scale. It's to do with the height of the towers compared to the height of the dome in the center. It's to do with the ratio of the smaller domes to the larger domes. It's to do with the way the archways work and the ratios of those archways to the big archway. So it's much more than just symmetry. And you might know that if that photograph took in that there are two more buildings on either side of the Taj Mahal that kind of add to the symmetry. So a very complex piece of mathematics to produce a very beautiful building. And then on the right hand side, these are called polydron, and those are magnetic versions of polydron. And I've been using those since that's a model that Felix made. Since Felix was born, I gave me an excuse to buy some polydron for home as well as as well as for in school, and been creating with it. And they play with it. I was going to say just play and stop myself, because it isn't just playing. It's using those pieces of material, using that resource to create three-dimensional shapes, and sometimes to create two-dimensional shapes. And we'll have a look at that on the next slide. That's the living room floor in our house. Thinking about the rug underneath, there's a lot of mathematics in that rug, isn't there? Which I hadn't noticed till then. There's mathematics in the tiles on the floor, in the stone flooring. But let's focus on those 3D shapes. I think Felix was about 5 when he made these shapes. Maybe a bit older, maybe 6 or 7. And he shouted me through, and he said, "Grandad, come through. I've made a city." So he's engaged in creative play, and he's made a city. And he said, "That Pentagon one is a sports stadium." And then he said, "It's not a Pentagon one, is it? It's kind of like," and he called it a big Pentagon. Hi, Emma. Yes, many. It took a lot of doing, didn't it? And a lot of drawing as well. And there's all sorts of discussion about the context, what we would now call workers' rights, isn't there, around that? And then he looked at the smaller ones, and he said, "And those cube ones." So that showed me he knew something about cuboids and cubes that he hadn't got the word yet for the 3D shape made out of pentagons. It's a dodecahedron, I think, that one. And he said, "No, that other one's not a cube, is it?" So I said, "It's a cuboid, rectangular prism," I think you would use in the Caribbean. And then he said, "And the other two, one's a sports stadium and one's a gym, and they're kind of the same, but kind of different, because they've both got squares and triangles." So he's noticing something about the shapes of the sides. So unprompted, he's using mathematical language to describe the properties of 3D shapes that he's made as a part of a creative play. And he's using those terms because we've used the correct terms for shapes, 2D and 3D, ever since they were small. And he's gradually developing and building his vocabulary. So that's another thing I think I'd like to emphasize, is always be using the correct terms. Don't correct a student who might say something incorrectly or tentatively. So Felix saying something like, "That's not a cube, it's kind of a bigger cube for the cuboid." I then said, "Yeah, it's a cuboid." And the people that I've talked to in Jamaica or in Belize call that a rectangular prism, at which point we might start talking about Belize and Jamaica. So it's just dropping the correct language, the correct terminology in as a part of that conversation, which is the way we develop all vocabulary, isn't it? So we have conversations, and that's how we develop vocabulary. We have mathematical conversations, and that's how we develop mathematical vocabulary. So I want you just to do something. We'll just spend 3 minutes on this. I want you to think how many different ways you can draw 6 squares so that all the squares touch along at least one edge. And there are 3 examples on that Max Maths page, at the top of that page. So just quickly draw as many different ways of arranging 6 squares as you can. Just sketch on a piece of paper. I hope you know by now that if you're doing a workshop with Tony, you're going to be doing some maths at some stage, or thinking about mathematics at some stage. And maybe just feed into the chat how many different ones you can find. It isn't just so I can have a slurp of my water and a little break. It's because I think you think differently about the mathematics if you're doing it. And I also think it takes you into the classroom, because the thing that teachers always do when they're engaged in any activity is think about, oh, how could I use this in my classroom practice? So another couple of minutes to start to be thinking about different ways you can arrange 6 squares. Yep, that's a nice way of there's one that looks like a T, Wilbert. So 3 squares along the top and 4 squares down a spine in the middle. Do you think that would that be a net of a cube, Wilbert? Have a think about whether that would be a net of a cube. I know what you mean. One, two, three, four, five, six in a kind of Z shape. Yeah, you could have 6 in a row lengthwise, 6 in a row up and down. Would we count those as the same? Would be another question. One, two, one that looks a little bit like a W. How many different ways of arranging squares did you find? Valerie's got 5. Has anybody got more than 5 ways? It honestly isn't a competition. I'm just interested in 3 above, 3 below. Yes, so a rectangle. If you've not already done this activity with students, um, do it. Do it tomorrow. Do it on Friday. So give them some squared paper and say, um, just as a question, how many ways can you join 6 squares so that all the squares join along one edge? And see how many they come up with. And you'll have conversations about whether if you flip a shape, it's the same or different. And it's just interesting having those conversations. If you rotate a shape, you're going to count it as the same or different. And then I move on to thinking about which of those form the net of a cube. Because I remember when I was at school, I was told this is the net of a cube, and given that top one, A in Max Maths. And then when I discovered there were other nets of cubes, I was quite surprised. And at first I thought, well, that can't be a net of a cube because I was told um, that the top one was the net of a cube. So I'd not done any mathematics in coming to understand the net of a cube. I'd just been given an answer. And the joy in geometry is the exploration and noticing the patterns and noticing the shapes. And those 3 at the top are all nets of cubes. And you'll discover, working the kids, that some unusual shapes give you nets of cubes. But Alicia and Valerie, who had the 3 above, 3 below, so a rectangle made out of 6 squares, will have realized, and you will realize, that that isn't a net of a cube. We can't fold that up to make a cube. So that then makes us think a little bit more about, well, what needs to happen in order to make a cube. And that leads to visualization, which we'll talk about a little bit later on. Another way of doing that, and this is often a way of doing something where you want students to think a bit about the mathematics, not just try and get you the right answer, would be to say, can you draw me a net of a cube? Now, my guess would be you might all have drawn A. And then say, can you draw me another net of a cube? A different net of a cube? And at that point, usually there's a bit of resistance. It's, well, I've answered the question. And what you're doing is creating what's called cognitive dissonance. It means that we have to think a bit about something. Something feels strange or unusual. But in that moment of strangeness, we start learning something new. Piaget talked about disequilibrium being needed for learning. And what that means is that a lot of the time, we're just kind of plodding along quite happily, not really noticing things, just doing stuff. Now, you may remember maths lessons from school when you were just plodding along quite happily, just noticing, not noticing stuff. And what disequilibrium does is shake that understanding, and you feel on shaky ground. And what you then have to do is think about your previous knowledge and how you can use that to make sense of this new situation and stop the ground from shaking. And that's called learning. So actually our job as teachers is to make the ground shake sometimes, because that's the way our learners will move on. So visualizing, I talked about visualizing, you sort of been able to see visualizing by folding up the cubes. And it's quite nice sometimes to ask students to look at the pattern of squares and say, will that make a cube? And you might see them moving their arms around to try and imagine or see in their head what happens. There's another example of visualizing from Max Math. So making a shape that you can squash. So making a square. There we've used ice cream sticks and pins in the corners. And then if we were to squeeze the two of the corners of the square, we can make a rhombus. And suddenly the properties of a rhombus make sense, because we can see a rhombus as a squashed square. So we know that those sides have to be all equal. They must have stayed the same. We know that the angles will be the same, but not right angles, because we've squashed it. And visualizing is an incredibly important skill to develop in terms of not just shape and space and geometry, but maths in general. So I'll read through that quote, which is from Mathematics Teaching, which is the journal I was talking about. We rely on visualizing when we solve problems. Sometimes we create an image of the situation that's being discussed in order to make sense of it. Sometimes we need to visualize a model that can represent the situation before we can begin to develop it. And sometimes we visualize to see what will happen if. What will happen if I squeeze that square together? There's a piece of research that led to the Van Heeler levels, which are levels in terms of learning geometry, and you'll see that visualization is at the beginning of there and zero. I am always suspicious of research that suggests things only ever happen in a particular order. Um, I've used the numbers because those are the numbers in the research. I would argue that people can come at those ideas in different orders and at different times, and often cycle through all of them. So I still need to visualize things before I move through those other um, levels, but sometimes I can actually move straight to proof just because of my experience of prior visualization, I suppose. So visualization, where we recognize a shape and we know it's the same as another shape that we've seen before, but we're not yet describing the properties. Analysis is when we start talking about the properties of shapes to classify them. Felix was doing that when he was having those conversations about those 3D models. Informal deduction, when we're starting to talk about general classifications. So it might be that we're beginning to understand there are all sorts of different kinds of triangles, not just equilateral triangles. Deduction is the stage when we're beginning to construct geometrical proofs, and you'll see there's a page from Max Maths, which is our way of starting to understand why the angles in a triangle sum to 180 degrees. And we can do that by dissecting the triangle and placing the angles along a line. And that's the beginning of deduction. And then post-primary school, then learners will begin to do more rigorous proofs. So there are 5 different levels in terms of geometry, but that just gives us the idea of the sorts of geometrical activities that we should be using. So in geometry, we should be asking that question, why? I wonder, why are there 360 degrees in a circle? Why are there 180 degrees in a triangle? Um, if we draw a line to a straight line, why do those two angles add up to 180? And it seems obvious to us, but it's worth asking that question of the learners, because otherwise they're just following instructions. There's no cognitive dissonance. Geometry is important in terms of position. Another key idea in geometry, or visualization, properties of shapes, the Van Heeler levels, but position. So moving from thinking about in front of and behind and next to, which Felix was doing as part of his description of those shapes. And that's why we spend a lot of time in the early years using positional language. When we're creating patterns, use positional language to describe those patterns, as well as using number, how many, as well as looking at the patterns. If it goes square, triangle, square, triangle, square, what's the next one going to be to make the pattern complete? So within geometry, all sorts of other kinds of mathematics. And over primary, we move from using the language of position in the early years, in grade 1, up to, I think that's from this book 6, where we're starting to think about translations, in this case, sliding a shape across a grid, and how we can use coordinate geometry, and it is called geometry, it's called coordinate geometry, to describe where a shape would be. So part of the development of mathematics and part of the development of mathematical language is becoming more and more precise in the way that we talk about mathematics. And what we need in terms of coordinate geometry is a precise way of describing where a shape will be. So that I could tell you, using coordinate geometry, I could give instructions to draw a shape, and you would draw exactly the same shape in exactly the same position. And sometimes that's quite an interesting way to start teaching coordinate geometry, is give instructions to create a simple pattern or a simple shape. And I think there's cognitive dissonance in that, because at the end you can say, now look at what your partner's got, now look at somebody else, and everybody has drawn exactly the same thing. And that's the point of coordinate geometry. That's why that's important. And then finally, in terms of geometry, thinking about symmetry. So back to the Taj Mahal, and obviously had to be very precise blueprints, very precise architectural designs for the finished product to look like that. And we can represent symmetry again using coordinate geometry. So these things all start to tie together, everything being connected. And by thinking about the image on the right hand side, the patterns of squares, we can start to think about the properties that are necessary for symmetry. Let's quickly move into thinking about measurement. So on the left hand side, two different sorts of pint glasses, and on the right hand side, a distance that I understand. And I understand, I was going to go for a run that would have been about 10k this morning. It's too icy. I had to stay in bed. Terrible. Have another cup of tea. Um, I know 10 kilometers is 6.25 miles. I know that these days it takes me about 65 minutes. As I get older, I know it used to take me 45 minutes, but I'm 63 now. I'm not 22 anymore. So I have a good understanding of those measures. Just quickly in the chat, any measures that you have a really good understanding of in terms of being able to visualize them, being able to work with them, being quite happy with those as measurements. I think it is, Lauren, and I think part of that does come back to our lack of confidence in mathematics sometimes, that we avoid using mathematical terminology in case we get it wrong. rather than having the conversation and then just checking later on that we're right. So yeah, just measures that you're quite happy with, measures that you can quickly visualize, quickly work with. Someone is typing, it's telling me. I don't know who. Yep. And I guess 25 meters sometimes, because 25. Why a meter, Ian? What is it that you have an image of when you see a meter? And how long's your shoe, Wilbert? Yes, I mean, I guess, Valerie, because I think you're in Jamaica, weren't you? So a cup is a measure. In the UK, a cup isn't a measure, so we might have different ideas. A meter rule, so you can see a meter rule. Um, and spoonfuls, and a teaspoon is 5 mils. And I know a teaspoon is 5 mils because of medicine, giving medicine quite often. Um, yeah, and cans of drink are 330 mils. Yeah, I'm the same with a pint. Now, interestingly, I understand what a pint looks like. I'm much less clear about a litre, what a litre looks like, because that's not a measure that I've used all of my life. I was in a bar last night, and I was talking about this session. Sorry, I bore people in bars sometimes, and I was kind of testing this out because there were people I was talking to were probably 20 years younger than me, but they still move between inches and centimeters. And they were saying it depends on what they're measuring, the image that they get. Yeah, so you've got an image of 5K and 1K. So there are lots. We say K though, don't we, Janelle? So we probably, yeah, in our heads it's a K. And I knew what you meant. 5 kilograms of flour, I mean, from going shopping. So we've got a real sense of what 5 kilograms feels like. So we have a sense of measure. Now, my argument from that is, if we provide our learners with lots of different examples of measures, they will end up with a much wider set of models to draw on, so that they can develop a better understanding of measure that we have. Thanks for that, Alicia. Um, I work a lot in schools where there's predominantly people from Indian extraction teaching, and they're or learning, and their mums often cook using different. They cup their hands in different ways to measure. So a teaspoon would be a very tightly cupped hand, and they kind of open it up for a tablespoon, and it was fascinating. And then we now have to know about how heavy luggage is, because otherwise it costs us. So within Max Maths, you'll find a lot of measurement activities where we're having to find something that measures a particular measure. And it would be interesting, again, if you go back to this, maybe have a look at these measures and think, well, do I know how much a milli? I know what 5 mils might be. Somebody said they know what 500 mils is. I know what a litre looks like. I wonder what 100 litres looks like. I wonder how much water there is in that swimming pool that's 50 meters long. I wonder how wide that swimming pool is that's 50 meters long. Why do I know how long it is, but not how wide it is, and so on. I quite often ask students somewhere that's a kilometre away from their school, or 10 kilometres, or a mile, or 10 miles, depending what units the school uses. Um, and that, like I say, gives us lots of images to draw on. Just quickly thinking about the progression in measurement and how that progresses across the school. We start off by comparing. So, like, we start off with positional language. We start off thinking about bigger and smaller, longer and longer and longest, short and shorter. And the important thing there is making sure we line things up at the same edge, and that's called conservation. So you'll see at the bottom of that slide, there's the same amount of water in each of those containers, but of course the height is different because the shape of the container is different. And that's another place that we can bring cognitive dissonance into play. So we could pour the liquid from container A into container B and ask the children, where do you think the water will come to? And they might say, well, it'll overflow because it's above the height of the container, and then be surprised when it doesn't overflow. And we can then talk about why that was the case. Start off with non-standard units and move to standard units. So we might start off by measuring in fingers, or start up measuring by paper clips, or measuring with little cubes. And then, because we're moving to being more accurate and being more precise, we have to agree on measurements. And the history of measurement is something interesting to talk about with learners, in terms of, because we've moved from non-standard units. So the Egyptians used cubits, which is that distance from the end of your elbow to the end of your fist, which is fine unless you want to reproduce something exactly the same somewhere else. So if we're building something in situ, we can use a non-standard unit, because that means that in relation to everything else within that building, things will be the same. But we couldn't build the same building somewhere else. That's right, handspans, yeah. And always estimating first. So the reason that whoever was it said no measuring, just estimating, I can't remember, sorry, I forgot. Build that in as a thing that you do. What do you think it's going to be? How many mils do you think are in this? Estimate 150 mils before you pour it in the measuring jug. See how close you were. And then we move from non-standard to standard. And I do think it's interesting having the conversation about the sorts of standard units we use. So friends in the Caribbean using imperial units, friends in Thailand using decimal units, the metric system. And then what we were able to do is move between the two. And when I'm running, Janelle was talking about running 5Ks. Being an old, now Janelle, I think you're in Jamaica, were you? Because Jamaica doesn't work in kilometers either. So my brain is still fixed in when I was at school in the 60s and 70s. So I move between kilometers and miles. And I know that 10K is 6.25 miles. So I can use that to work out the other distances. And so I know 5 is going to be 3 1/8, because that's half of 10, and so on. I know that 1 is 0.625 because I can divide by 10. I know that 0.625 is 5/8, because I can connect things, connect different areas of mathematics together. And so I can move between those things. I rarely do the 1.6 to 1 calculation, but I do sometimes, or that a kilometre is 5/8 of a mile. And then sometimes there are direct links between measures and particular aspects of number. Obviously, there's counting involved in terms of measuring and reading a scale. That's counting, really, isn't it? We're using a number line. Another activity I might encourage you to and it appears in Max Maths, is making cuboids out of different numbers of 1 centimetre cubes. I know in the Caribbean curriculum, it appears as understanding about volume made up of unit cubes. And it's quite a nice activity to do anyway, because the students will then understand why we talk about cubic centimeters. It's because it's a cube. We're counting cubes that are centimeters. If I've got 48 1 centimeter cubes, there's one cuboid I could make, which is 3 by 4 by 4, 3 times 4 times 4, which gives me 48. Now I can make, there's many different cuboids I can make. I could make a 1 times 1 times 48 cuboid, for example. And what we're actually doing is exploring factors. And what we can also do is explore prime factors, but our starting point is measurement and geometry. So I'm using that one there to bring together all of those ideas, which is why I said at the beginning that we can't say that because we're good at shape or good at measurement, that somehow that's a lesser form of mathematics than being skilled in number, because all of those things come together. And there's the final slide. And there are 3 young people, 2 young people, 2 of them Felix and one's Tate. I say 3 because that little baby was just before their little cousin Wilf was born. We were thinking about how they might act when they first met Wilf, so they had a little baby. And Tate wanted to bake cakes for baby Wilf. And you can see their connections. He was measuring in order to bake those cakes. He's cutting out numbers. He went on to organize those numbers in a particular way. Felix making pizza, geometry, angles when he cuts that up evenly and measure. And in the bottom, he's making jerk chicken. And that's during lockdown. And we went on an imaginary holiday to Jamaica because I'd been to Jamaica. And we talked about the currency and we talked about how big Jamaica was. And we compared that size to Manchester, which is somewhere that he knows. We talked about there being a Manchester in Jamaica and a Manchester in the UK. We talked about speed in terms of running and how fast that was and how far could he get in 9.9 seconds and how far short of 100 meters that was. So all sorts of mathematics in his particular context at the time, but doing number, measure, geometry, everything all connected. 3 o'clock exactly. I was much better in my timing this time. Thanks, Valerie, for saying that. It's just working on it, so it's kind of quite exciting being not good at measurement because in some ways it gives you more to work on and more to think about, and think about all of the ways that you measure at home and take those into the classroom. Do those activities in the classroom. That's a nice way of looking at it, Lauren, as well, saying bilingual in the language of measurement. That's a great way of looking at it. Thanks, Catherine.
Thank you very much, Tony. That was brilliant. Lots of really good examples in the chat as well there. Thank you everyone for joining us today. As I mentioned at the start, you will be sent the recording of today's session and the slides and your certificate. So keep an eye on your inboxes. And if you attended all 4 sessions this week, you will receive a special certificate. So keep an eye on your emails. And thank you very much, everyone, for joining us. Lots of thank yous in the chat. It's fantastic to have so many people from all over the world join our webinars. So yeah, it's really, really great. Thank you so much. And thank you very much to our lovely presenter, Tony.
Thank you all. No, I've really enjoyed that. And doing these sessions is fantastic for me because it allows me to rethink things, and it actually does mean that I work differently the next time I'm working with kids, because it's always teaching makes you think about something differently, doesn't it? And your comments help me rethink that as well.
Great. Thank you so much, everyone. And please do reach out to us on the details shown on the screen if you've got any questions, or please do follow our social media channels as well. We're always posting helpful resources and lots more on there. So do have a look at those, and hopefully we will see you all very soon. And have a good day, evening, afternoon, wherever you are. Thank you very much. Thank you, Tony.
Thanks.
Bye.
Bye-bye. Bye, everybody.